All right. Hello, everyone. Welcome back to MDE 54. So since this week we're covering stuff from chapter 8, which quite honestly, I don't really feel the need to go into really much more detail in an MDE course. There's not a lot of backtracking we can do. We're going to take a different approach today and possibly next class. So today, what we're going to do is I'm going to call it a review, but I'm also going to call it a review involving problems that you can just run into in the real world, whether it's in literally this classroom or just going to the grocery store or going to go check out a gym membership with 2 options or just talking about inflation rates, anything like that. So we're going to do about 9 examples and then we'll call it a day. Some have multiple parts. And then next time, we're probably actually going to talk about some stuff from chapter 9, even though we won't need to have talked about chapter 9 first, because it's just going to be basic Excel math, most of which we've already seen, just with an extra column or 2. So with that being said, let's go ahead and get into it. So some real world review examples. And I was actually looking at this a couple days ago. One Life was offering a promotional offer. They were offering an offer. So they were offering a promotional discount where instead of, I think, $250 for joining at the $30 rate, they were only going to make you put $100 down. And then I think the other one was $100 down at the $40 rate was reduced to $50 down. And I've seen this come up a couple different times. So it's not the first time that this has happened, and it won't be the last. So One Life offers 2 different membership options during these occasional specials. One is going to run you $30 per month, so probably $29.99, but we're just calling it 30 for the sake of simplicity, with an initial $100 down payment. The other option is you will pay $40 on a monthly basis, but you only have to put $50 down. Now, a lot of people will look at that and say, oh, I only have to pay $50 up front. I'm going to take that and just pay the $40 monthly. But here's the thing, is that really the best option for you? How many months are you going to join this gym? 1 month? 2 months? Are you going to be there for a year? Are you going to be there for 5 years? Because the amount of time that you spend there is going to determine whether you should go with what I'll call option A or option B. So we're going to do the math to decide how to pick the cheaper plan for yourself. Notice I don't say you're going to be there 15 months. Which plan do you choose? You're going to be there 5 months. Which plan do you choose? I'm leaving this open-ended, which means we need to find what I'd call the equilibrium point where it would cost the same. So we need to find the point at which they cost the same. And then from there, we can determine when we should choose plan A and when we should choose plan B. So plan A is where we have the $30 variable rate, a monthly basis, and the $100 fixed rate or fixed cost. So variable cost, variable rate. Let me change that to variable cost. Whereas plan B has the higher variable cost, but the lower fixed cost. And of course, all of these are in dollars. We like to put our units when we are dealing with quantitative reasoning. So $30 variable cost or with a $100 fixed cost versus $40 variable cost and a $50 fixed cost. So what we need to do is look at the total cost of plan A. We need to look at the total cost of plan B. So the total cost A is going to be equal to the variable cost plus the fixed cost. But remember, a variable cost isn't just that $30, it's $30 times the variable. So you can use whatever letter in the world you like, X, A, B, M. I'm going to go M for number of months. So we'll say the variable cost is $30 times M. So again, M being the number of months, plus the fixed cost. So this is the standard linear model we talked about throughout chapter 5. It's a variable amount plus the fixed amount, where the 30M is going to be the variable amount. 30 times the number of months, $30 times the number of months. So that means if you go for 1 month, you're paying $30, 30 times 1. If you go for 2 months, that's 30 times 2, $60. 3 months, that would be 30 times 3, which would be $90. But then you also have to add in that initial fee of 100, meaning it would have been 130 or 160 or 190. Then the total cost B would be its variable cost of $40 per month times the number of months, plus its fixed cost of $50. Now it's not $50 per month, it's just $50. And then if you want to say somewhere where M is the number of months, this is us being very thorough. All right, so I mentioned earlier, we want to find the what I call the equilibrium point, where plan A would cost the exact amount of plan B, because before that number of months, one is going to be cheaper than the other, and after that number of months, vice versa. So let's set the total cost of A equal to the total cost of B, TC being total cost. So that's what we're going to do. We're going to set the equation for the total cost of A equal to the equation for the total cost of B. So we get 30M plus 100 is equal to 40M plus 50. And then from here, we're just going to do our basic algebra. So we want to solve for M. We got 30M on the left, 40M on the right. So it doesn't matter which way we move things. I like to keep things positive for the variable. So let's subtract 30M on both sides. Those would cancel, giving us 100 on the left equals 40 minus 30 is 10. But we still have the variable M. We're going to bring down to 50. But we can't just leave it as 10M50. Make sure you have your plus sign there. Then let's, oh, I meant to change colors there. That's my bad. Go back to black. 100 equals 10M plus our 50. There we go. Now we will subtract. We want to keep the variables all on one side and the constants on the other. So let's subtract 50 on both sides, which will give us 50 is equal to 10M. And then we're going to divide both sides by the 10. Just go over here. 50 divided by 10 is 5. So 5 is equal to M. The 10s here would cancel. 10, anything divided by itself is always 1. So that says 5 equals M. Well, what is M? M is months. So that would be 5 months is where they should be the same. I don't know why I keep putting a period there. So 5 months is the equilibrium point. But the question was not to find the equilibrium point, to find when the cost of plan A is the same as plan B. It says to decide how to pick the cheaper plan for yourself. So let's say Bob, person A, is going to be at this gym for a year, which is 12 months. Which plan would Bob want to go to? Well, you could do the math if you actually have to do it. You could put 12 into the total cost for A, into the total cost for B. I'm going to leave that as an exercise for my students to figure out what those would be. And whichever one is cheaper, I hope that's obvious that's what Bob would want to go with. Or you could just use some slight logic and reasoning if you would prefer that. A higher fixed cost means that you're going to pay more initially. The lower variable cost means you're going to pay less in the long run. So if you're going to go past this equilibrium point, you would rather go with the cheaper monthly cost. So anything past 5 months means that you should go with plan A. You would want to only pay $30 a month. You'd rather go ahead and pay that $100 up front, just get that balloon payment out of the way, because if you're going to be here for 12 months, 24 months, 36 months, 100 months, however long, 10 years, who knows, you want to go with that lower variable rate. But if you're only going to go to this gym for 2 or 3 months, maybe you like swimming in the summertime, but when it's not warm enough to swim outside, you got to find an indoor pool. So maybe you're just going to join One Life for like 3 months, you know, December, January, February, or even 4 months, December through March. Then maybe you want to take that lower fixed cost with a higher variable rate to save yourself 10 or 20 or 30 bucks. So again, I'm not saying plan A is better. I'm not saying plan B is better. It depends on what you are going to do. Are you going to be at this gym for 1, 2, 3, or 4 months? Then go with plan B. Take the lower fixed cost, the lower upfront cost. Are you going to be here long term? Then you need to take the lower variable cost. And One Life is not the only type of place that offers these kind of A and B options. Cell phone plans, you'll see them out there. All right. Example 2. Sorry, I've got my windows open because it's a nice day. I don't know if you heard that motorcycle, but I definitely did. Bob has the following averages in his Math 154 course. 75 for his My Math Lab homework, 40 for his Excel homework. Bob must not be doing all his Excel homework. 85 for the quizzes, 100 for his participation. I like to think that everybody's getting hundreds. That's not always the case. And he got an 81 on his midterm. And we ask, what is Bob's current average? Now, I didn't actually give you what the weights are for this because it's in your syllabus. It's something that I would hope you know at this point in the semester. Now, if this was an exam problem or a homework problem, of course, those numbers would be in front of you. Maybe not a quiz problem because you would have resources to look up. But the weights, just as an FYI, the My Math Lab homeworks are 15%. The Excel homeworks are also 15%. Your quizzes are also 15%. Your participation is 10%. Your midterm, as well as the final, is 20%. The only thing left over is the project, which is 5%, coming up soon. So what's his current average? Well, our weighted average, you were supposed to remember that formula. That is something you're supposed to have memorized. It's the sum products of the weights times the data values divided by the weights. Now remember, for these percentages, the 15s, the 10s, the 20s, you can have them as decimals, so 0.15, 0.1, and 0.2, or as whole numbers, 15s, 10s, and 20s, as long as you're consistent. I'm going to go with whole numbers, just because that's what I'm going to do today. So it'll be 15 times the 75. So that's our My Math Lab homework. So 15% times the 75 we earned, plus the Excel, that would be 15% times the 40 we earned, plus the quizzes, that's 15% times the 85 we earned, plus the participation, that's 10% times the 100 we earned, plus the midterm, that's 20% times the 81 we earned. That's all we have. This course is not complete yet, so I'm not going to add in the project. I'm not going to add in the final. Maybe that'll be part B, hint, wink, nudge. And then we divide by the sum of the weights. The weights we have are the 15, the 15, the 15, the 10, and the 20. And I'm going to go ahead and pull out a calculator just to keep us moving along. Trusty TI-83. So we got our 15 times 75, which is going to be 1125. I'll set this up a little nicer. Go. So 1125 plus the 15 times our 40, which is going to be 600, plus the 15. Oh yeah, I can't do that. I'm just going to use my mouse. 15 times 85. That's going to be 1275. Then the 10 times 100 is obviously 1,000. The 20 times the 81 is going to be 1620. Oh, shoot. $16.20, and then all divided by 15 and 15 and 15 is 45, plus 10 is 55, plus 20 is 75. And then we can add the tops. That was 112. I keep doing that. 1125 plus 600 plus 1275. 1,000, 1620, That's 5620 divided by our 75. So we can just take that and divide it by 75. And we get 74.93. Let's just round that to the nearest tenth and call it a 74.9. Obviously, in terms of actual grades, we call that a 75, which would be a letter grade of a C. Not the worst, not the best. Now, does this make sense? Well, I would say that this makes sense. We've got a midterm of a super low B. My math lab is a C. Our quizzes is kind of a mid-range C. Participation doesn't really count for too much. So that's nice. But that Excel homework is really going to drag us down. If that Excel homework had been, say, an 80, that could have the potential to have brought us up to a low B. But it is what it is. All right. So Bob later earns for Part B an 83 on the final exam and a 90 on his project. What's his final average? Now, I haven't changed any of my math lab homeworks, any quizzes, or any Excel homework. So we're just going to say that in example 2A, we already had everything submitted for those first three categories, and the participation did not change. So all we're going to do is just add in a couple extra numbers. We're going to add in the 83 for the final, which counts as 20%, and the 90 for the project, which counts as 5%. I just wrote 10, I meant to write 20 for the final. And then 5%. Project's not very much. So what's his final average? All we're going to do is literally just copy paste what we had for the weighted average, but then in A, but we're going to also have the final exam and the project now in their place. So our weighted average, 15 times 75, plus 15 times 40, plus 15 times 85, plus 10 times 100, plus 20 times 81, plus. Now the new stuff, and I'll do in blue the new stuff. The final was 83, so 20 times 83, and then the project was 5% times the 90. Divided by, again, we originally had our homework, quizzes, participation, midterm. Now we've got the final and the project. Now all the black numbers are still going to be the same for the top, so that's going to be 1125 plus 600 plus 1275 plus 1000 plus 1620 plus, but now we have the 20 times 83. Which is going to be 1660, and then the 5 times the 10 is going to be 50. So 1660 and 50 will be new numbers. 1660 and 50, and then all over. Now I'm going to go ahead and combine the bottoms. The original denominator was 75. We're now adding a 20, which is 95, and another 5, which is 100. Shouldn't really be a surprise. When you have a full class, you're accounting for all 100 percentage points. So our weighted average. So the original top was 5620. That's the sum of all these black numbers. I can just add the two blue numbers. So that was 5620 plus the 1660, which you can't see on my screen currently, plus the 50. And that'll be 7330. Divided by, not 50, 100. And actually, this is pretty easy to divide. Dividing by 100 just moves the decimal left twice, so we get a 73.3. And I'm sorry, I was pausing there because I realized I had a mistake. I was like, something's gone wrong. I wrote 5 times 10 here. I'm pretty sure I meant to say 5 times 100, which means this 50 would be 500. So I need to fix that because I was sitting here going through, does it make sense? We had a 75 originally and a 73.3 here. If our final exam and our project are higher than our previous average, why would our final average be lower? That wouldn't make sense. That couldn't have been right. So we need to erase this stuff. Sorry about that. And again, that was 5 times 100 because we did not earn. I'm sorry, 5. Not, oh, I know what it was. It's not 100. It's a 90. It still isn't right. You can see that 9. I was just writing a little too quick. It's not 5 times 10, that's 5 times 90. Silly me with my bad handwriting. Well, 9 times 5 is 45, so add a 0, and that's 450. All right, so that was 5620 for the black numbers originally in the top. So let's take our 5620, sorry about that again, plus the 1660, those are the final points, plus the 450, which gives the top being actually 7730, divided by 100. Then when we move the decimal left twice, we get 77.3, which would be about a 77, which would still be a C, but a slightly higher C. So see how I made a mistake here, and like I've said in this class many times, I like to make some mistakes intentionally, some accidentally. This was an accidental one. But when I looked at the answer, I knew to ask myself, does it make sense? And it didn't make sense. My weighted average should not have been lower since I made higher grades. So we still have a C. The slightly higher final exam grade versus the midterm grade, the slightly higher project weren't enough at this point to bring our grade up a full letter. We would have needed maybe to have some higher Excel grades or a couple higher my math lab grades, something like that. All right. Example 3. We're at the grocery store and considering 2 brands of eggs. One is $3.50 for a dozen, and the other is $5 for 18 eggs. What is the better value? Notice I don't say what's the better egg. We're not considering quality here. So maybe one of these brands is going to be, you're going to get those nice orange organic yolks, and the other is just your super cheap eggs that are in facilities that aren't the best. We're just looking for the best cost per unit, which is exactly what we do here. We take the costs and divide it by how much we get. So for what we'll call A, that's where we're going to have $3.50 for a dozen. We take the cost, we divide it by how much we get. So it's $3.50 divided by 12. And we get 0.291666666. So let's just round to 3 decimal places, so 0.292. Now you might say, well, why not round to 2? Because we're talking money. It might be good enough, it might not. Sometimes when you go to this cost per analysis, you need a couple decimal points. So let's go 0.292. 0.292 per egg, because that was 12 eggs. Then for B, we're looking at $5 divided by 18 eggs. See how much it helps to write our units. So we took 5 divided by 18. 5 divided by 18. And we get 0.2777777. So if we round into 3 decimal places, that would be 0.278. And that would be per egg. So it would have actually been fine to go to the nearest penny here, but again, sometimes cost analysis gets very meticulous and you need to go an extra decimal or 2 places into things. So which one do we want? Do we want the 29 cents per egg or the 28 cents per egg? Well, if you're just going purely based on cost analysis and not quality, you want to go with the cheaper one. So brand B is the better value, but not by much. So if you try out brand A and you really love them, you try out brand B and they're fine, they're good enough, but again, you're not getting those nice orange yolks with all the nutrients and blah, blah, blah. Maybe that 1 penny per egg is not really worth the savings. Or maybe you are an absolute penny pincher and you have to deal with this. All right. Getting a little silly from here on out every now and then. In the country of Babistan, our favorite resident Bob, the CPI in 2020 was 130 and the CPI in 2021 was 155. It's a pretty big leap, in my opinion. So if you earned 40,000 Bob bucks in 2020, we can't say dollars because the Babistan's not using the American dollar, they're using Bob bucks. So if you earned 40,000 Bob bucks in 2020, what would your salary need to be in 2021 to keep up exactly with inflation? So this is a great question right here. How much more money do you need to actually make to ensure that you're able to have the exact same lifestyle as before? Well, we're going to do proportional reasoning here. We're going to set a fraction equal to a fraction. And remember, you can use your words. It's good to use your units. So we're going to put Chuck E. Cheese tokens. That's great. So we're going to put our CPI over our, I mean, you can do this several ways. You can compare one CPI to another. You can compare the CPI to the cost, as long as you're consistent. So let's go CPI over the dollar amount. Bob bucks. And we're going to have one side be 2020 and the other side be 2021. So in 2020, the CPI was 130 and our Bob bucks, we were making 40 grand. But then in the next year, the CPI rose to 155 and we have an unknown amount of Bob bucks to match our lifestyle. Well, we're just going to cross multiply this. CM means cross multiply. So we take the 130 times the X. We take the 155 times the 40,000. I'm going to go ahead and multiply that. 130 times, not 130, excuse me, 155 times the 40 grand. That's 620 and then 4 more zeros. So if you want to put commas in here just to help you, that's 6,200,000. And then this is a nice easy linear equation. We're going to divide both sides by 130 so that the 130s will cancel. And then we'll get X is equal to, we got to do the math. We can just divide that by 130. And we get 47,692 Bob bucks and 31 cents if you round to the nearest cent. We're just going to assume we're going to still call it cents since we call the dollar a buck. So 47692, 30, did I say 31? 31, yes. Bob bucks. Now, does this make sense? Well, it's more than it was originally. So the CPI was higher, so we would assume that we would need more money to account for the inflation. Now the CPI didn't double or triple and the salary didn't double or triple. So I would say this is within the sense of reason. So you would have to make an extra 7,692.31 cents, 31 bobbins, whatever you want to call them, in order to maintain the same lifestyle. Now, is that a guarantee? Not necessarily. Maybe you're a person who buys way more electronics. Maybe you're a person who buys way more fuel. Maybe you're a person who buys way more real estate. And these things may or may not inflate the same. And if you're following news, especially in 2021, you would see that. What was the rate of inflation from 2020 to 2021 in this scenario? How does this compare to the USA's long-term average as discussed in class? Now, if you recall, we said that our government likes to see our long-term inflation be around 2% per year. It has not always been the case. In the 70s, it was almost double digits sometimes. In 2021, we're seeing a 6% inflation. But again, the long-term average has always floated about 2%. So that's what I'm referring to. So how can we calculate the rate of inflation? Well, you could compare one of two things. You could compare how much money Bob previously needed to how much he previously needs, or you can just compare the CPIs, and it's literally the same math either way. So we are going to calculate a rate of change. We're going to do that subtraction and division. We take the old and the new and we subtract them in the appropriate order, and we divide by either the old or the new, whichever it is. So as a reminder, your increase or decrease is going to be the new minus the old divided by the old. Now you can do this again with the CPI values or the dollar amounts. I think CPIs being triple digit numbers is going to be easier to deal with. So let's deal with the 130 and the 155. 155 minus 130 divided by 130. 155 minus 130 is going to be 25 divided by 130. Let's pull out that trusty calculator. 25 divided by 130. And we get 0.1923 blah, 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 blah. Now, this is not 0.19%. This is a decimal value. You have to convert this to a percent. Decimal goes left, excuse me, right twice. That's 19.23%. So how does that compare? This is higher than the USA's traditional average. It's higher than even practically any rate of increase we've ever had. I can't think of any particular years where our inflation was higher than 19%. But don't hold me to that. All right, example 5. If you were a state employee, you probably, they didn't all earn it, but you probably earned a 5% pay raise in 2021. Also, just so you know, you earned no pay raise in 2020. You get a pay raise about every other year for the past 15 years as a Virginia state employee, just FYI, pointing in my direction. If inflation the same year is calculated at 6.2%, that number may or may not have just come out. Did you actually get a pay raise in 2021? Explain. So you might say, well, yeah, you got a pay raise, you make more money. But if all the goods and services that you pay for have all inflated on average at 6.2%, if you are purchasing exactly what the government says would be every single human in the USA's, all their different purchases, your purchases now cost you 6.2% more. So if you were paying $100 on average for whatever before, you're now paying $106.20 because everything went up 6.2%. Now again, gas went up a lot in the past year. It went up like 50%, especially because people weren't really moving around a lot in 2020, so gas prices were super low because of that. Restaurant costs went up significantly. Electronics, honestly, didn't really increase that much. As I've mentioned in class previously, electronics tend to go down in price over time. Now you might say, well, not if you get the brand new iPhone 13 or 14 or 17 QR, whatever, which may not exist yet. Well, yeah, if you're buying brand new, super high-end, fancy technology, that's another story if it's never existed before. We're talking about the technology that has existed before. Computers in the mid-90s cost $2,000, $3,000 in 1995 dollars. It's like a $7,000 computer now. Whereas now you can go get a tablet for 150 bucks. And that would be able to do way more than that computer from 95. So again, just going down to big averages, you earned a 5% pay raise, but inflation was 6.2%. Did you actually get a pay raise? Well, sadly, no. You actually lost money. You lost 1.2% of your previously purchasing power. I don't know why I chose to handwrite this instead of type it, but that's okay. Because you earned 5% more, but lost 6.2% due to inflation, the $100 that you had before is now really only going to be worth 98.8% of what it used to be. So your $100 is now worth $98.80 on whatever it is that you can go out and buy. If you're buying lots and lots and lots of gasoline, it's going to be worth way less than that. Do all goods inflate the same from year to year? I already answered this as part of the previous question, so this was just kind of a kicker. No, not at all. Now you might say, well, fuel inflated insanely this year. That doesn't mean it's going to be the same next year. It could drop 20% next year because of the overinflation that we felt from this year. Maybe people start traveling less because of that massive increased fuel cost. Maybe people stop dining out so much because everything costs 40% more if you're going to a nice restaurant. Chains didn't really increase that 30–40%. So on average, it might not be as significant. But then you also have the high turnover rate with employees at these restaurants. And a lot of places are offering, not necessarily the best service because of brand new employees, way too many people wanting to go there, not enough employees. And it's just out of their control. I'm not saying that's a bad thing and these people should be shamed for that. It's not at all what I'm saying. It's out of their control. Insurance costs, they inflate differently. Medical expenses, they inflate differently. The cost of tuition at schools, they inflate differently. The past couple of years, we've had a tuition freeze in most states, but that's probably not going to last forever. We might have free community college in the next 5 or 10 years if that ever comes down the pipeline. If someone doesn't offer it, then not actually give it up. Maybe that would be a great thing for us one day. But no, all goods do not inflate the same. Real estate has gone up. Real estate has gone up because of supply and demand issues on top of lower interest rates overall. All right. Bob's significant other sends him to Floor & Decor, specific store, for some new tile. Bathroom tile, floor tile for the kitchen, whatever, who knows, who cares. The SO, we're going to say significant other, has measured the room that the tile is being replaced in to be 12 feet by 16 feet. How much tile does Bob need to buy exactly to cover the floor? Well, he needs, we're talking about a surface area here, which is just a length times a width. We're talking about a rectangular room. We're going to ignore any super minor details, little cutouts, little rectangles that don't need to be there in addition. We're just saying it's exactly rectangle. So he needs 12 feet by 16 feet. We're just taking 12 times 16. You can pull out your calculator if you need to. 12 times 16. We get 192. So that's 192. I don't know why I just chose to do that. Let's be consistent. 192 feet, question mark? No, feet would be wrong. Because when you multiply units, you get units squared. We talked about that previously. So feet squared, or you can just call them square feet. So Bob needs to purchase 192 square feet of tile to cover this floor exactly. So Bob goes to the store and he has the intention of buying 192 square feet of tile. Bob comes home and eventually, after Bob puts everything down, he gets yelled at by the significant other because it wasn't enough to cover everything, because Bob probably made some miscuts on this tile cutter. Bob probably dropped a tile at some point and broke it, or there were these weird little sections you had to cut out, or maybe the room isn't perfectly symmetric, blah, 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 whatever. So when you go to the store for your project, what you should do is buy a little more than you need. And most stores are nice enough that if you have any whole tiles, you can still return them. So how much more should you buy? Well, that's going to depend on your opinion. 10, 20%, 25%. These are numbers that contractors will throw around. I'm just going to go with 15% to kind of keep it in the middle. So Bob plans on purchasing an extra 15% to be safe for these miscuts, non-exact fits, dropping one because Bob's a little clumsy. Nobody's perfect. How much should Bob actually purchase? So we need to purchase an extra 15% of materials. So the extra, did it go away? There it is. Would be 15% times how much we needed originally to actually cover the floor, which was 192 square feet. Well, 15% as a decimal is 0.15. So that's 0.15 times 192. 0.15 times 192. So we need an extra 28.8 square feet of materials. Meaning the total that we need to purchase would be how much we really need, 192 square feet, plus the extra, which would be 28.8 square feet. If you really need to pull out the calculator for that, you can. So 192 plus the 28.8, then we get 220.8 square feet. They might say, Mr. Beckner, why couldn't you have just taken a shortcut? Why couldn't you have just said, all right, well, we need 115% of materials, so you just take 1.15 times the base value of 192. You're absolutely correct. You get the same exact value. Do I care how you arrive at that value? No. Do I care that you can calculate the value one way or another? Yes. So if you need an absolute minimum of 192 square feet, if you want to purchase 15% extra, you need 220.8 square feet. Maybe you're going to be ultra safe and say, I need 25% extra. 1.25 times the 220.8 means you should go and purchase 276 square feet. We're not going to be ultra safe. We're going to stick to the 15%. Bob goes to the store and all the tiles are measured in inches or square inches more appropriately. So square inches for the surface area, but then inches by inches. So 6 inches by 12 inches or 11 inches by 11 inches. Well, Bob's significant other didn't know this because they didn't go to store with them initially. They just said, oh yeah, it's, you know, this much by this much. Feet's easier to deal with. Let's stick with feet. So whatever is Bob to do? Well, Bob's going to need to do some unit conversions. He's going to need to convert his square inches to square feet or vice versa. And it doesn't matter which way, we're only going to do the math for one. In particular, the tile that Bob and his significant other have picked out measure 11 inches by 11 inches. So it's a square tile, but it's not a foot by a foot, it's almost a foot by almost a foot. How many tiles will Bob need to buy? So that's the ultimate question. How much are we actually going to purchase? And you could take this one step further. If the cost per tile is $1.10, multiply that out, but you'll get the point by that. All right, let me give myself a little more space here. Should be good. All right, so we know that we need 220.8 square feet, but we got to convert this to square inches. Let's convert this to square inches, and I hope that we remember, I really do, that 12 inches is 1 foot. So we take our 220.8 feet squared, and we got to do dimensional analysis out with the old and with the new. Because the old units are feet, that means we need feet going in the bottom, and the new units in the top we're converting to inches. And we know that 1 foot is 12 inches. So if you do the math here, you multiply the 220 by 0.8 by 12, you'll get a number, but it's not going to be good enough because feet squared is not going to cancel feet. Feet squared is only going to cancel with, feet is only going to cancel with one of the feet squared. So we have to do that multiplier twice. We have to multiply by 12 inches over 1 foot. Again, if we were dealing with cubic units, there'd be 3 of these. So then that second foot in the bottom will cancel with the second foot in the top. Now, if that's inches and that's inches, that means that our answer will be in inches squared. Anything times itself is itself squared. And we can just do the math, the product of 220.8 times 12 times 12, since those 12s are in the top. If the 12s have been in the bottom, we divide. And we get big number, 31795.2. 31795.2 square inches. A whole lot of square inches. So this is how much we need. But how many tiles is this? Well, each tile is 11 inches by 11 inches. One tile is 11 inches times 11 inches. 11 times 11 is 121. Inches times inches is inches squared. So we need to figure out how many tiles we need. We need this much inches squared total, where one tile is this many inches squared total. All we got to do is just divide them. We want to cancel the units out. So the number of tiles would be the 31795.2 inches squared. That's the total surface area we need divided by how much one tile is, 121 inches squared. So our units will cancel, giving us just a number of tiles in total. Take that 31795.2, we divide it by 121. And we get 262.77. We can't buy 0.77 of a tile. So even if this was 262.1, we would round in a very unique way. If this was 262.1, I would still round up because you can't buy 0.1 of a tile. So no matter what, you would round up even if you wouldn't traditionally. So 263, it's a terrible looking 3 tiles. Tiles quite often will come in boxes of 10 or 100, depending on what it is, or 20. You could do the number of boxes you got to purchase from there. You can also buy loose tiles. You do whatever you got to do. All right. January 1st, no year said, there's 2 infected people. That's it. On February 1st, 1 month later, the news claims that the number of infected people has increased 1,000% since January 1st. Oh my God, everything's on fire. The world's ending. 1,000% increase. This is awful. Holy cow. Well, Bob and his significant other are watching the news in the kitchen while cooking dinner, and the significant other is starting to worry. Bob sees this news and explains to the significant other, because the significant other hasn't had Math 154, why the news is pandering, as they quite often do. He turns off the news and then turns on something much less fear-mongering. Explain the math and logic Bob covered to the significant other and why that nobody should be worrying in this scenario. I'm not saying this mirrors what's been happening in our world. This is a unique scenario. We had 2 people infected. A month later, there's 1,000% increase in the number of infected. Now, I'm not saying that maybe this scenario doesn't turn into something bad ultimately. Right now, it doesn't look bad when you think about this in a Math 154 sense, when you quantitatively reason. Well, our increase rate is 1,000%. So our increase, or rate of increase, was 1,000%. So we're going to find the new based on the old times the growth factor. And remember that the growth factor is 1 plus the increase, the rate. Now that rate has to be a decimal. 1,000% as a decimal, moving the decimal left twice is 10. So 1 month later, the new amount of people infected is the old, which was 2 people, times the growth factor of 1 plus 10. Because again, the 1,000% increase as a decimal is 10. The growth factor is 1 plus the rate of increase as a decimal. Well, 1 plus 10 is 11, so that's 2 times 11, which is 22. So on February 1st, there's 22 people infected. Why is the news pandering? Oh, 1,000%. Oh my God, we should talk about this for hours and hours and hours and hours, and every day at 3 o'clock, 5 o'clock, 9 o'clock, 9 a.m. Well, you went from 2 people to 22 people. That's 20 more people that got infected. Is that significant? No, it's not significant, not yet at least. Does it mean that maybe 3 months from now it's not going to be significant? No, of course. We can't see into the future. But over 1 month, 20 more people being infected, this seems like pandering to me. Now, if this had happened in a day and it kept getting worse and worse and worse, that's another story entirely. So this is why we turned the news off for this particular example. All right, last problem for the day and we'll let you out. A different virus is spreading at a current rate, notice I said current rate, of 20 million people per day. Oh, wow. That is a fast spread. That's faster than any spread we've seen, honestly. So this is talking about just the USA. We're ignoring all other countries, and we're going to call the USA population 330 million people, which is about what it is today. Now, the news claims that this rate is going to be the same for the next month. Now, the news makes some bad analysis every now and then. Explain and show some math why this is impossible. Go into detail about what you think would be more likely to happen. So I'm already saying this is impossible. It's not possible for the current rate to be 20 million per people in the USA, 20 million people per day, if the population is 330 million. So over the next month, if we're increasing by 20 million people per day, how many days are in a month? Well, let's go with the average of 30. You might say 30, 31, whatever. So there's 30 days per month. Well, 20 times 30 is 600. Your days are going to cancel. And that says that we're increasing at a rate of 600 million people per month. Why is this impossible? Because the population is only 330 million. How are we going to increase the number of infected by 600 million when that's almost twice as many people? I'm just going to round it out and say twice the number of USA people. It's impossible. So sure, the rate is really awful today when it's 20 million people per day. But what do you think is more likely going to happen? Well, once someone's infected, they're not going to get infected again, at least for a very long time until there's mutations, something like that. So once someone's infected, let's just say it's done. They're done. Well, if there's 330 million people, let's say maybe currently there's 100 million people infected, and the second day there's 120, and the third day there's 140, and the next day there's 160. Maybe it's consistent for a while. But eventually, the infected people are going to be around a lot less people that aren't infected. They're going to be around mostly infected people, which means they're not going to spread it as much. So eventually, I'm not going to be able to do this. I'll have to handwrite it. That's okay. The rate has to slow down since there's less people to infect. Now, this is either A, because they've already been infected, B, because they've been vaccinated, C, whatever. But it's going to slow down, and it's going to slow down, and it's going to slow down until eventually it's almost nothing. Now, mutations happen, and people can get infected again, but we're just looking at a short-term claim here. It's going to have to slow down pretty soon. All right. So I just thought that this would be a fun set of exercises to do. Again, just kind of taking stuff almost all the way back from the beginning of this course up to what we've been talking about more recently, a little bit of logic and reasoning, a little bit of grade analysis, a little bit of proportional reasoning, some percent change. I thought this would be a good summary because this is this is a great summary of how you can use the material from this course outside of the classroom. Yeah, there's a lot of problems in this course that you're never going to see again. But you can still use the concepts and basic math of this course in your almost everyday life. So I really hope that a week from now, a month from now, a year from now, that you'll still be able to use some of this, especially once we get into the finance talk. Hopefully you'll remember some of that later. And you're not necessarily use me as your financial advisor, because I'm not that. That's your own decisions to make, but to at least hopefully use that to improve your financial life in one way or another. All right. So like I said, next time when we come back, we're going to do some stuff with Excel. We don't really have to talk about too much in Chapter 8 in the MDE course. When we go back to Math 154, we'll be doing 8.3, but again, MDE, we'll talk about some Excel stuff, some retirement, accounting for inflation. And then once we get to Chapter 9 in Math 154, we'll talk about Chapter 9 stuff in MDE 54 as well. Also, the very last day of class, we're probably just going to do a final exam review, kind of like we did with the midterm review. I think that'll be a good idea for everybody. But besides that, as always, if you have any questions, shoot me an email. Keep working on your homework. Remember, you are still supposed to be keeping up with your homework. I don't want to have to fail anybody that gets an A, B, or C in Math 154 because they stopped doing their MDE 54 homework. Remember, there's no real due dates except for you have to have everything done by the day of the final exam. So if you've fallen a couple weeks behind on your MDE 54 homework, this would be a great time to catch up on that. All right, take care, everybody.